All right, so now from the British Isles, we are going to move to the Philippines. And I want to welcome Ren Divien, Obeña. Are you here with us? Oh, thank you. There you are. Yeah, she's a master's student in environmental science and management. All right, but you are working on a very, very interesting topic as well. So the factors influencing vegetation structure in forests over limestone. So please go ahead.
Good day. On behalf of my colleagues in Conserve Kaigangan, allow me to present our paper entitled Factors Influencing Vegetation Structure in Forests over Limestone of Guiuan Marine Resource Protected Landscape and Seascape or GMRPLS, Samar Island, Philippines. In Philippines, Samar Island is known to house vast area of forests over limestone. Locally known as Kaigangan, it provides numerous ecosystem services to the surrounding communities. Despite the benefits obtained from these ecosystems, these resources are vulnerable to degradation. Aside from anthropogenic disturbances, human-induced pressures are exacerbated by the frequent occurrence of typhoon in the area due to its geographic location. Kaigangan in GMRPLS. There have been insufficient studies or no published research on the environmental factors influencing vegetation structure of forests over limestone in GMRPLS, or worse, remain unexplored and unknown to science, resulting in a scarcity of information. Hence, the Kaigangan in the GMRPLS should be subjected to several studies to elucidate the role they play and to better understand the dynamics of change in species distribution on this landscape that benefits both humans and nature. The objectives of this study are to identify the woody vegetation structure of GMRPLS and to determine the environmental factors influencing the characteristic physiognomy and ecology of GMRPLS forests over limestone. This study was carried out in 4 barangays of the municipality of Guiuan, namely Pagnamitan, Baras, Ngolos, and Solangan. These barangays are part of the GMRPLS, which is located on the southern tip of Samar Island. The team used the quadrat or plot method to conduct a floristic inventory in the sampling site. A total of 9 20 meters by 20 meters vegetation sampling plots were set up across the 4 barangays. The identification of species were verified through the help of experts and secondary literature. The recorded species were then classified based on their conservation status following the updated National List of Threatened Plants in the Philippines or DAO 2017-11 and the IUCN Red List. For vegetation analysis, the importance value of each species was computed by determining the density, relative density, frequency, basal area, and relative basal area of species per plot. The species diversity was also computed using the Shannon-Wiener Index, Simpson's Diversity Index, and Fisher's Alpha. The dominance analysis was computed using the formula of Osawa in 1984. Cluster analysis was done using the relative basal area of trees per plot. Jacquard Index was calculated from the dataset using past software. A dendrogram was then constructed using the unweighted pair group method with arithmetic mean hierarchical clustering method. 3 replicates of soil samples were collected in each plot. These samples were homogenized per plot and sent for soil analysis. Secondary data was used to gather the information about the 30-year monthly temperature and rainfall in the area. To determine the interaction between the 3 species and environmental variables, canonical correspondence analysis was used for ordination. The floristic composition in GMRPLS. There are 1,050 individuals with 35 woody species belonging to 16 families recorded in the forest over limestone of GMRPLS. Among these, 11 species are endemic to the Philippines, which includes the Monoon oblongifolium, Heterospathe intermedia, Shorea stylosa, Shorea negrosensis, Ansea wenzeliana, Nataphobelaitensis, Artocarpus blancoi, Bistonia copelandi, Neoneclea formicara, and Gonostylus reticulatus. Based on the assessment of IUC and Red List, the threatened woody species found in GMRPLS are the following: Hansea wenzeliana, Shorea astylosa, Heterospathe intermedia, Colloquium luscianense, and Daquilaria comediana. The locals in Samar use the timber of Hansea wenzeliana for housing and construction materials, as well as fuel wood or charcoal. In the Philippines, this endemic species is distributed in the province of Surigao del Norte in Mindanao. The Heterospathe intermedia is an endemic plant species which was grown as an ornamental plant. The locals in summer use the leaves to make walls and floors coverings. Aquilaria comediana is commonly known as agar wood and is known for its highly prized resin extracted from the bark. On the other hand, the threatened woody species found in GMR PLS based on the Dow 2017-11 are the following: Shorea astylosa, Shorea negrosensis, Valaciodendron salabicum, Palacium luscianense, Aquilaria comediana, Saribus rotundifolius, and Artocarpus rubivenus. The timber of Valaciodendron salabicum is used for furniture. Locals in Samar reported using it in the same way. We also collect these species for seedling propagation. The Valaciodendron salabicum is distributed in the areas of Sulawesi and Philippines. The Artocarpus rubivenus can be used for construction and as material for wood carving. Its bark also has medicinal property. This species is endemic to the Philippines and distributed to the provinces of Batan, Albay, Aurora, Bataan, Batangas, Camarines, Isabela, Laguna, Pampanga, Quezon, Rizal, Sorsogon, and Mindoro. The diversity of each plot in Guiuan ranges from very low to moderate level with values ranging from 1.252 and 2.279. Based on the results, plot 2 was observed to have highest number of species and most diverse among all plots with Shannon-Wiener index value of 2.521, whereas the highest number of individuals was observed in plot 6 with 172 individuals. There are no disturbances observed in these plots. Also, both plots were located at higher elevation among other plots ranging from 72 to 93 MASL. Consequently, the lowest number of species was observed in plot 3 with 7 species and plot 8 with 8 species, while the lowest number of individuals was found in plot 1 and plot 8 with 61 and 63 individuals respectively. Furthermore, plot 8 was situated in the lowest elevation among all the plots and was observed to be disturbed by human activities. The cluster analysis of woody species revealed 3 clusters of vegetation with similarity index of around 0.4. Each cluster was named based on the highest value of the dominant species per plot in the cluster analysis. These clusters are Cluster 1, Hansea, Colophyllum, Cluster 2, Bagoeho, Shorea, and Cluster 3, Stercolia and Alstonia. Cluster 1, Hansea Calophyllum cluster. Cluster 1 was observed in 2 plots, plot 1 and plot 2 with a similarity index of around 0.58. The elevation of these plots range from 90 to 94 MASL. These plots are situated in the highest elevation among the other sampling plots. The dominant species in this cluster, based on RBA, were Hansea wenzeliana, Sterculia comosa, Alstonia scolaris, Macaranga tanarius, dalunutan, bayarong, and Valaciodendron salabicum. Moreover, this cluster had the highest number of species with 23 species, the most diverse with Shannon index value of 2.521. The highest TBH value observed on this cluster is 63.66 cm from species of Valaciodendron salabicum, and the maximum height is 27 meters from Macaranga tanarius. This cluster also has the least number of individuals per hectare with a value of 2562.5. Cluster 2, Bagoeho Stercolia Cluster. Cluster 2 is delineated at around a similarity index of 0.61, which comprises of 3 plots including plot 9, plot 8, and plot 5. The elevation of these plots range from 31 to 66 MASL. The dominant species based on the RBA were Bagoeho, Artocarpus rubivenus, Valaciodendron salabicum, Colloquium luchanense, and Shorea stylosa. The highest DBH value on this cluster is 54.11 centimeters, recorded in the species of Shorea stylosa and Colloquium luchanense, while the maximum height value is 20 meters in Ficus Palma and Bago Ejo. Cluster 3 is Turcolia Estonia cluster. Cluster 3 has a similarity index of around 0.5 and consists of 4 plots. This includes plot 7, plot 6, plot 4, and plot 3 with elevations ranging from 49 to 85 MASL. The dominant species based on RBA were Turcolia comosa, Ficus minaceae, Bridelia glauca, Bayarong, Artocarpus blancoi, Monoon oblongifolium, and Alstonia scolaris. Furthermore, this cluster had the maximum DBH value of 63.66 centimeters for Artocarpus blancoi, Stercolia comosa, and Ficus minaceae. The maximum height is 20 meters for the species of Artocarpus blancoi, Stercolia comosa, Bridelia glauca, and Ficus sp. Also, this cluster had the highest number of individuals per hectare with value of 3,300. The ordination diagram of CCA shows sampling plots, species, temperature, elevation, disturbance, and 14 edaphic variables. It illustrates the ordination plot with species, represented by blue circles, sampling plots with red squares, and the environmental variables with green arrows. Environmental variables with long arrows are more strongly correlated with the ordination axis than those with short arrows, and thus more closely related to the pattern of community variation shown in the ordination diagram. Different species found in different sampling plots in GMRPLS responded differently to the environment and their community structure changes. The factors influencing the vegetation structure of GMRPLS are organic matter, manganese, nitrogen, elevation, and temperature. Other factors, despite their lesser significance, have indirect and multiple effects on the distribution of some species in GMRPLS. Axis 2 is associated with organic matter value, which has strong relationship with plot 1 and negatively relationship with plot 3 and 5. Most species present in plot 1 are not observed in plot 3 and plot 5. These are the species of Rhytia sp, Calophyllum solatri, Shorea negrosensis, Aquilaria cumingiana, and Bayarong, which are all positively correlated with organic matter, while the species of Colloquium sp1, which was only found in plot 3, is negatively correlated with organic matter. Manganese. Manganese is also associated with axis 2 and is strongly correlated with plot 3 and negative to plot 1. This edaphic factor was also observed to influence the dominant species found in plot 3, which are Bridelia glauca and Neonuclea formicara, locally known as hambabalod, where the latter species is absent in plot 1. Nitrogen. The nitrogen has negative score in axis 2 and has strong relationship with plot 2. Most of the species that is positively correlated with nitrogen are only present in plot 2. These are the Saribus rotuntifolius, Mastitia sp, Amahoyan, Kuyakya, and Dalunutad, while the Bridelia glauca and Neonuclea formicara or hambabalud, which are negatively associated with nitrogen, was not observed in plot 2. Elevation and temperature. The elevation has negative association with axis 1 while opposite with temperature, which has strong relationship with these axes. Plot 8 was greatly correlated with both these environmental parameters. Among all plots, plot 8 has lowest value of elevation and has highest value of temperature. This relationship is also observed in the dominant species of plot 8, which is Bago Ejo. To conclude, a combined effect of various environmental factors influences the structural vegetation of GMRPLS. It is noteworthy to take into consideration the influence of anthropogenic activities. Indeed, there is a need to safeguard our landscape and seascape. our team would like to thank Department of Science and Technology and Philippine Council for Agriculture and Aquatic Resources Research Development, Department of Environment and Natural Resources Region 8, SINP Protected Area Management Board, GMRPLS Protected Area Management Board, Basaranan nga Organisasyon Hansan Isidro Paranas, tour guides and boat operators for River Protection Environmental Development Organization, and DOST Science Education Institute. This ends my presentation. Thank you for listening.
Thank you very much, Ren Divien. This was a very interesting presentation. We have one question in the chat. Let me see. What can you recommend to protect the mother trees in the protected area?
Currently, actually this study is part of our project, the first implementation and the second phase of the project. So for the second phase of the project, we are identifying species that that are critically important in this ecosystem. And one recommendation we will be using is the establishing of nursery in the area. We will tap the local units, local government units, and the people's organization in the area to help them build a nursery in Samar Island.
Yeah, I guess that's very interesting to involve the communities also in the measures to take, right? Because
yes,
otherwise it won't succeed. I have another question. Are seeds allowed to be taken from the area? Habito is asking.
We acquired a permit to take seeds, but as much as possible, we will be using a propagation techniques in the nursery. So before it will be deployed to the communities.
Thank you very much. We have time for one more question. If someone in the chat or live wants to ask Ren Divien. If not, I would like to ask you something, because yeah, it's very interesting, all the environmental factors that you consider, but how about the human pressure? Did you put that one in the equation? Because I can imagine that the low elevation sites are more accessible and might be more prone to harvesting by local communities than the high elevation sites.
Yes, we also included that variable. We take into consideration that variable, and somehow the disturbance is also correlated with the elevation, since, as you say, it is more accessible for the people in the areas that has lower elevation. So in terms of it greatly affect the plot number 8, as you can see in the CCA. I'm sorry if the CCA picture is you cannot see the disturbance arrow that is somehow related with the plot 8, which is we also observe to have anthropogenic disturbances during our field work.
Okay.
Yes,
I see. Now, thank you very much, Ren Divien. Good luck with the rest of your project. It's very interesting.
Thank you very much.